I am using it, but I have an extra one. All right, so we're doing 6-7 today, and it is graphing inequalities. Okay, so 6-7, graphing and solving inequalities. Okay, so what if I ask you to, I'm just going to dive right in. So if I ask you to graph y is less than or equal to x squared minus 6x plus 2. Okay, it's a parabola, correct? Mm-hmm. All right, and there's two ways, remember I taught you to get it in vertex form. One is to complete the square.
Opposite b over 2a.
The other one is opposite of b over 2a. So the x is going to be the opposite of negative 6 over 2 times 1, which is 6 over 2, which is 3. And therefore y would be 3 squared minus 6 times 3 plus 2. So that's 9 minus 18 plus 2, which is negative 7. So the vertex is at 3, negative 7. So we know it is y is less than or equal to x minus 3 squared or minus 7. Okay. If this had been like a 2x squared, we'd put a 2 out here. Anything that's a comes there. All right. So now to graph it, the vertex is at 3, 7, 3, negative 7. 3, 1, 2, 3, 4, 5, 6, 7. So it's 3, negative 7. Excuse me, there is a roach on this table. There was a roach on this table. It's now dead. All right. Okay.
I think it is.
What now?
I think that is.
Oh, that would be funny. Well, my commentary is going to be on there. I don't think you'll be able to see the roach. But, all right.
You said that so calm.
So, okay, so here's the vertex. Does it open up or down from there?
Opens up.
Up. Okay. And here's your axis of symmetry. Right? So I would do 2 points to the right. So I would do a T-chart with 4 and 5. Okay. For 4, you've got y equals 4 squared minus 6 times 4 plus 2. Well, that's 16 minus 24 plus 2. That is negative 8 plus 2 is negative 6. So 4, negative 6 is a point, which means 3, negative 6 is a point because they're symmetric. Then for 5, you've got y equals 5 squared minus 6 times 5 plus 2. That is 25 minus 30 plus 2, which is negative 3. So 5, negative 3 is a point, which means 2, negative 3 is a point. So here, that is the line or the curve y equals that. Okay? So we draw it solid because equals that is a part. It's in the solution. It's less than or equal to. So now we're either going to shade inside or outside since it's an inequality. Well, there's two ways you can decide. The way your book teaches, I don't really like. The way your book teaches is they say plug in the origin. X is 0, y is 0. So that would be 0 is less than or equal to 0 squared minus 6 times 0 plus 2. 0 is less than or equal to 2. Is that true? Yes. So the region with the origin needs to be colored in because it's true, which is out here because there's the origin. It's on the outside. Okay? Does that make sense?
Mm-hmm.
If what we had gotten was not true, we would know that the region with the origin should not be colored in and it should be the inside. Okay? The way I like to do it, so that's one way, and that's perfectly fine if you want to do it the way. What I do is, if you've got y is less than or y is greater than, so your y is on the left and everything else is on the right. If you go to the vertex, since it's less than, go down and shade wherever you end up. Okay? So let's say you had graphed this parabola, and it was y is less than or equal to blah, 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 blah. Go to the vertex, go down, shade that region. So it'd be inside. Okay? If it were y is greater than, go to the vertex, go up, and shade that region. So that would be outside. So don't remember it as less than is inside or less than. It's just less than, you go down and shade whether that be inside or outside. Greater than, you go up and shade whatever that is, whether it be inside or outside. Okay? Let's do some more. All right. Here we go. All right. Okay. Do you want to complete the square or do the opposite of b over 2a? Okay. So to complete the square, we're going to take 4 over here. So we've got y plus 4 is less than x squared plus 3x, right? Then if there were anything here in front of the x squared, we'd factor it out. But there's not, so we don't do that. So then you just complete the square. Take half of this number. Half of 3 is 3 halves. And you square it, which is 9 over 4. To both sides. Well, 4 is 16 over 4. This becomes x plus 3 halves squared. And so that is y plus 25 over 4 is less than x plus 3 halves squared. If you subtract that, y is less than x plus 3 halves squared minus 25 over 4. Okay. So where is your vertex?
At negative 3 halves, negative 25.
Okay, well that is negative 1.5. And negative 25 over 4 is almost negative 6. Or almost, it's a little more than negative 6. Right there. Okay, does it open up or down from there?
Up.
Up. And what I would do is plug in a t-chart with 2 points to the right. So I would do negative 1 and 0. 0 is easy because it'd be 0 plus 3. 0 plus 0 minus 4 would be negative 4. So 0, negative 4, which means negative 3, negative 4. Okay? And then negative 1 would be y equals negative 1 squared plus 3 times negative 1 minus 4. Well, that's 1 minus 3 minus 4 is negative 6. on either side. Now, since this is just y is less than, you don't draw this solid. You draw it dotted. Okay? Two methods to know which side to shade. It's less than, so you go to the vertex and go down. Is that inside or outside? Vertex, go down, outside. So you would shade out here.
Wait, how did you figure that out?
Since it's less than, you go to the vertex and go down.
Okay.
If it had been greater than, you go to the vertex and go up. Okay? What now? The next 2 points were -1 and 0, and I plugged them in to the original equation. The other way is to test the origin. So is 0 less than 0 squared plus 3 times 0 minus 4? 0 less than -4? No. So since it's not, the area that has the origin in it should not be shaded, and the other part should be. Okay? So two methods to do it to know which part to shade. Okay? Now what about if I ask you to solve this? Now there's two methods. You can do it by graphing, and you can do it by factoring. I'm going to show you both of them. You only have to do one, but I'm going to show you both of them. One is to graph y equals x squared minus 6x minus 7 and see when is that less than 0. Okay? Well, if you graph that, just to save you some time, I'm going to show you that the vertex is at 3, -16. Okay. And here's your parabola. Right? We want to know when is your y value less than or equal to 0? So if you drew a line, there's 2 points where it is 0, and here is everywhere where it's less than, right? So what you need to do is find those two zeros, and it's everything in between them. Well, you can find those zeros by either factoring or doing the quadratic formula, and you see that it's x is -1 or x is +7. So the answer is all x's between -1 and 7. Now, if it said greater than, it would have been these two pieces, right? And that would have been x is less than -1 or x is greater than 7. Okay, a way I probably like a little better is by graphing. So we've got x squared minus 6x minus 7 is less than 0. Well, let's figure out when does it equal 0. Well, if you factor, that's x minus 7, x plus 1, right? This gives you x equals 7. This gives you x equals -1. So if you look at a number line, at -1 we're 0. Is 0 less than 0? No. At -1, this whole value is 0. Is 0 less than 0? No, so we don't color that in. What about at 7? At 7, we're 0. Is 0 less than 0? No, so we don't color that in. But we have cut the number line into 3 pieces. If you cut a hole there, cut a hole there. So all you have to do is test any point on each of these 3 pieces. What's the number that's over here? Negative 3. If you plug in a negative 3, negative 3 minus 7 is negative. Negative 3 plus 1 is negative. What's negative times negative? Positive. So it's positive everywhere on this piece. Another way, you could have plugged negative 3 into this and seen that you got a positive answer. Either way. What's the number on this piece? 5. 5 minus 7 is negative. 5 plus 1 is positive. What's negative times positive? Negative. What about a number over here?
The 9.
9. 9 minus 7 is positive. 9 plus 1 is positive. Positive times positive is positive. Now, which ones do we want?
The negative.
The negatives. So that's where you get negative 1 is less than x is less than 7.
You said you like graphing better?
I like factoring better.
Yeah, I like that. I hate
Okay? Let's do 2 more. First one is a word problem. A rectangle is 6 centimeters longer than it is wide. Okay, so a rectangle is 6 centimeters longer than it is wide. Find the possible dimensions if the area must be more than 216. Okay. Okay, so here we go. We've got a rectangle. We don't know the width, so let's call that x. But if that's x, what's the length? X plus 6. And then the area is length times width, right? Would be x plus 6 times x, which is x squared plus 6x. We need that to be more than 216. So x squared plus 6x is greater than 216. Now, if it said it must be at least 216, we would do greater than or equal to. But wants to be greater than 216. Okay, well, you've got to get this greater than or equal to 0. So you subtract 216, and you get that. Okay. So then you've got a quadratic to solve, okay? You can either factor or do the quadratic formula or complete the square, I guess, if you wanted to. We need the factors of 216 that subtract to be 6. So 1 and 216 doesn't work. 2 and 108 doesn't work. 3 and 72 doesn't work. 4 and 54 doesn't work. 5 doesn't go into 216. 6 and 36 doesn't work. 7 doesn't go into 216. 8 and 27 doesn't work. 9 and 24 doesn't work, but we're close. 10 doesn't go into there. 11 doesn't go into there. 12 and 18. There we go. Okay, so it's going to be x plus 18, x minus 12, right?
Mm-hmm.
Which that gives us negative 18 and positive 12, right? Now we don't color those in because equals 0 is not an option. But we've now got 3 pieces to test. If you do negative 19, negative 19 plus 18 is negative. Negative 19 minus 12 is negative. Negative times a negative is positive. Okay, number here, 0. Always choose 0 if you can. 0 plus 18 is positive. 0 minus 12 is negative. Positive times negative is negative. Number over here, 13. 13 plus 18 is positive. 13 minus 12 is positive. Positive times positive is positive. Now, which ones do we want, positive or negative? Positive. So that means x is less than negative 18 or x is greater than 12. Can we throw one of those out? X is a length. So nothing less than negative 18 would work. So the answer is the width must be greater than 12 centimeters. Okay? Are we good?
Mm-hmm.
All right, let's do one more.
It's gonna be another word problem?
No. Thank you. Okay. So it's already equal to 0. So you can either factor or do the quadratic formula. It factors to be x minus 4, x plus 3. So that gives us x equals 4 and x equals negative 3. Okay, at negative 3 it's 0. Is 0 greater than or equal to 0?
No. What?
Is 0 greater than or equal to 0? Yes. So we color that in because 0 equals 0. At 4, it was 0. Is 0 greater than or equal to 0? Yes, so we color that in. If that had just said greater than, you wouldn't have colored these in. But because it says greater than or equal to, you do. Now we got to test the 3 parts. Negative 4. Negative 4 minus 4 is negative. Negative 4 plus 3 is negative. Negative times negative is positive on this piece. What's the number between negative 3 and 4? 0. Always use 0 if you can. 0 minus 4 is negative. 0 plus 3 is positive. Negative times positive is negative. Then 5. 5 minus 4 is positive. 5 plus 3 is positive. Positive times positive is positive. Do we want the positives or the negatives? Positives. So the answer is x is less than or equal to negative 3 or x is greater than or equal to 4. Make sense? Okay. Yes. What now? I don't understand what you're asking. Sorry.
I didn't get the question
When x is negative 3, this whole thing is 0. Is 0 greater than or equal to 0? Yes, so we have to color it in at negative 3. Because negative 3 is a solution to it. Okay? If we just had this, negative 3 would not be a solution because 0 is not greater than 0. But because we have this, negative 3 is a solution. We have to color it in. Okay? All right. The last thing we're going to do, and I'm just going to introduce it, is 6-8. I'm going to talk about standard deviation.
Should we take notes on this?
Yes. Okay. So let's say that student 1 made the following grades. Student 2 made the following grades. Okay? Both of them have an average of 95. But do you see these sets of numbers look very different? What's different about student 1 and student 2? On the report card, they would have the exact same grade.
Student 1 only had 5 grades.
Well, that is part of it, but if I added this.
Student 2, like, the numbers are,
Yeah, student 1, his average was 95. The most he made was 1 point over that. The least he made was 1 point lower, right? So it was 95, and he was consistently 95. Bumped up to 96 one day, down to 94 one day, but everything else was just straight 95. Student 2 only made 95 once. Every other time, they were at least 5 points off, sometimes 10 points off, okay? So theirs is more spread out than here, okay? So a lot of times with data, just knowing the average doesn't give you enough information. Because if we only knew the average, it says both students scored a 95. We would think that they scored about the same on everything, right? But when you look at it, it's very different. And so there is a way to measure how spread out things are, okay? And that is called the standard deviation. So my definition is a measure of how spread out data values are. Or another one is a measure of how much data deviates from the mean. Deviate means to go off, okay? So, does student 1 have a higher or lower standard deviation than student 2? Lower. Student 1 hardly deviates, so they would have a very low standard deviation. Student 2 jumps all over the place, so they would have a really high standard deviation. Okay? Now, I'm going to teach you how to find these on your calculator, but let's just start, and I'm going to do it for student 1 and student 2, calculate the standard deviation. I'm going to teach you how to do it by hand, and then I'm going to teach you how to do it on the calculator for a lot of data points. When you just have 6 like this, then it's not bad, okay? First thing you do is list all the data points. So let's do student 2 first. So we got 95, we got 90, we got 100, 100, 100, 85. Actually, I think 85 may be wrong, because it's supposed to be 80. Okay? Go back and change that one to 80. It's supposed to be 80 if the average is going to be 95. Okay? All right. So the first thing you do is find the mean. And I told you it was 95. Okay? Then for each point, you do what's called x minus the mean. So if the mean's 95, what is x minus the mean for 95? 0. What's x minus the mean for 90? Negative 5. What about for 100? 5. 100. 5. 100. 5. Negative 10. 15, sorry. Wait, did I have it right? You know, this is supposed to be, this was 85. Sorry, I had it right the first time and then I changed it. Because these numbers need to all cancel if you add them up.
Oh, they need to cancel?
The amount you are over a mean and under a mean have to cancel. That's why the mean is what it is. All the points above and all the points below have to cancel out. Okay? So that's how I know without even calculating the mean that this had to be 85 because we were 15 points above, only 5 below, so we needed 10 more below. Okay? All right, so once you do that, then you square it. Okay? So that is 0, that's 25, that's 25, that's 25, that's 25, that's 100. Okay? Then you average these numbers and take the square root. So you find the mean, find x minus x bar for every point. Square x minus x bar. Find the square root of the mean of x minus x bar squared. Okay, so how would we find the mean of these 6 points? I mean, mean of these 6 numbers. You're going to add them up. And divide by 6. So that's 200 divided by 6, right? And then you take the square root of that. So that would be square root of 200, which is 10 root 2 over the square root of 6. If you multiply top and bottom by the square root of 6, you get 10 square root of 2 times 2 times 3 over 6. 2 comes out, so that's 20 square root 3 over 6, which is 10 square root 3 over 3. That's your standard deviation. Or you could have given a decimal approximation. They usually just do decimals. Okay? Somebody got a calculator. What is 10 square root 3 divided by 3?
That's 5.775.
What'd you say?
5.7735.
Which makes sense. This says, on average, you're a little more than 5 away from the mean. Does that make sense? This one wasn't, but this one was 10 away. So if you average those, that's 5 away, right? 0 and 10. And the rest of these were 5. So on average, now it is about, because you do square and square root, it gets a little bit off. But yeah, just about, on average, you were about 5.7 away from the mean, okay? Let's do the other set of values. So we've got, this one's going to be much easier. We got 95, 96, 94, 95, 95, 95. So the first thing we're going to do is find the mean, which was 95. Then you do x minus the mean, so that'd be 0, 1, negative 1, 0, 0, 0, right? Then you square it, 0, 1, 1, 0, 0, 0. Then you average it, 0 plus 1 plus 1 plus 0 plus 0 plus 0 divided by 6 is 2/6 or 1/3. And you take the square root of that. So that's 1 over the square root of 3, which is square root of 3 over 3. Okay? Now that, what'd you say? Okay? Which says, on average, you're about 0.5 away. Which makes sense. If you average 1s and 0s, you get something around 0.5. Okay? Does that make sense? And it's much less than the other one. The other one was 5.77. On average, you were more than 5 points away. Here, on average, you're less than 1 point away, which is true. Make sense? Okay. That is it. Let me give you your homework. And the homework is just going to be 6, 7. It's not going to have the standard deviation stuff on there. Okay. 1 second. Let me find it. No. I have it written down, but I can pull it up on the app.
No, I got practice today.
Okay, your homework is page 382, 27, 34, 39, 42, 43, 44, 48, 49, 52, 53, 57, 58. And test corrections due Monday. All right?